how as well. So what we're going to do is we're going to just start talking about angles in standard form. One thing that you need to understand is that there are positive angles and there are negative angles. Okay? And what I do, the best way I can explain that to you is you put your car in drive, or a vehicle gets put in drive, the wheels rotate forwards, correct? You put it in reverse, what do the wheels do? They go the opposite direction. So when we start talking about the unit circle next week, we're going to talk about the rotation of angles, okay? Most of everything that we do is going to be in degree, but we are going to have to talk about a different unit of measure called radians, and I'll explain that to you today as well. So some of the definitions that you need. All right, an angle on the coordinate plane in standard form. When the vertex is in standard form, I apologize, is when the vertex is on the origin and one ray lies on the positive x-axis. So here's your positive x-axis. And notice that it rotates. So here's your terminal side, okay? All right, so the ray on the x-axis is called the initial side. Goodness gracious. So basically the positive x-axis is where we start the majority of our rotations. The other ray is called the terminal side because that's where you terminate. So this is the initial side, and this ray would be the terminal side. Notice the marking, because we can rotate one way, we can also rotate a different way, and the different rotations, one is positive, the other one is a negative rotation. So when you draw your angles, you have to make sure that you do the markings so that I know that you're referring to the positive angle and not the negative rotation. So counterclockwise rotations result in positive angle measures. So this is counterclockwise. Okay, because don't most clocks, if this is 12, then that's 3. Most clocks rotate this way. Okay, so we're going from 3 back to 12, so that's counterclockwise. And then clockwise rotations result in negative angle measures. So this rotation, and just for clarification, theta, that symbol is called theta, just in case you didn't know. That's a Greek letter. It's no different than R, X, Y, or Z, but the Greeks were contributed with discovering Trig, so we get to use their Greek alphabet. We use alphas, we use betas, we use thetas. So you're going to see some different symbolism from time to time. So in this particular picture, that's a positive theta rotation. But if I were to go this way, that would be a negative theta. That's a negative movement rotating clockwise. Okay. The most common unit of measure for angles is degrees. And you know the little degree symbol. And a degree is equivalent to 1 over 360 degrees of a full rotation. So the first 6 problems that we're going to do, we're just going to sketch positive and negative angles. So we start at 0, we rotate, and notice that they just keep adding increments of 90. Now, sometimes you have to rotate. Could you imagine if you got in your car and your tire only rotated once? and no more, you wouldn't go very far, would you? Okay, so your tires rotate and rotate and rotate. So the more they rotate, the bigger the angle is going to be because you're way past 360. So I saw this 415, so we're going to have to deal with that one. So 65 degrees, positive 65 degrees. We will start here. So I'll draw those in red. This is our initial side. And we will rotate this way, not quite to 90. And I will put my markings there. So that is a 65-degree angle. Rough estimate, not exact. I'd have to pull out my protractor if I wanted it to be exact. Okay. Now remember, we start here. We go to 90, 180, 270, 360. So we're looking for where these angles fall. So 320, do you agree, would fall between 270 and 360? So over here somewhere, not exactly if I'm sure if I've got it in the exact spot, but it's in the right quadrant because it's between 270 and 360. Start here and show your rotation because that's a positive angle. Now, since 415 is bigger than one complete 360 rotation, I'm going to go start on positive X. I'm going to rotate around one full time. And then I need to calculate how much more. So I'm going to take 415 and subtract it from 360. What do you get when you subtract 415 from 360? 55 degrees. So I've gone the full 360 and I need to go an additional 55 degrees. So once you start getting over 360 or even rotate in a negative direction, which puts you past that negative 360 mark, you start getting what I call the snail shells. That kind of looks like a little bit of a snail shell. And the more you rotate, the more of a snail shell. If y'all don't know what I'm talking about, look in the corner back here on the wall. You see the shell? And you see how it kind of does that little spiral thing? That's why I call it a snail shell, because it reminds me of that picture when I draw it. Now, negative 140, okay? So the way the negative angles work, if this is 0 and you rotate this way, that is negative 90 degrees. And if you keep rotating, this is negative 180 degrees. If you keep rotating, you're at negative 270. And then once you hit full circle, you are at negative 360. So the rotation is different. We're rotating in a different direction. Here, we're rotating in a counterclockwise for the positives. Here, you're going in a clockwise movement. All right. So negative 140 would actually end up over here somewhere between negative 90 and negative 180. So when I draw the arrow, I have to draw the arrow rotating in a clockwise fashion, and that would indicate the negative movement. Negative 15 degrees would be in quadrant 4 because it has to fall between 0 and negative 90. So that's not going to be very far away. So pretty small little angle. 210 degrees, negative 210 degrees. Which quadrant are you going to end up in? 1, 2, 3, or 4? 2? Because this is negative 90, negative 180, so you have to go a little bit further. So yes, you would end up in quadrant 2. Negative 210 and positive 210 do not fall in the same quadrant. Positive 210 would be here. Negative 210 is here. The terminal side of your angle is very, very important. And I'm going to kind of step away from this for just a minute and explain to you why it's very important. If you were to plot a point in first quadrant, do you agree it's positive x and positive y? Y'all agree? Okay, same thing here. Positive x, positive y. If I'm in second quadrant, that's a negative x and a positive y coordinate every time you plot a point there, correct? Same thing here, negative x, positive y. That does not change. Second quadrant doesn't move just because I'm rotating in a different direction. So here you get negative x, negative y when you plot points down here. Same thing here. Now, here's negative 210, and this is positive 210. Negative 210 has a negative x and a positive y coordinate that will go with it. Positive 210, both coordinates are negative. So where you terminate and how you rotate is very, very important, because a negative x positive y is not the same thing as a negative x and a negative y. Does that make sense? Okay. I don't know if that made sense or not, because you were also very, very quiet. What's the ordered pair that you would always get when you plot a point in fourth quadrant? This was negative x, this is negative y, so what would this one be? Positive x, negative y. It works both ways, positive x, negative y. Just because we're rotating different directions, those values never change. Make sense? All right, so radian measures. You may be asked to deal with radian measures, okay? You are very comfortable with degrees, all right? So what happens is a radian is a unit of an angle measure based on arc length. This is the arc, so we're talking about the length. So what is the length of that arc that is cut by a given angle, okay? 1 radian is defined as the measure of the angle formed with the radius, and it is equivalent to the length of the intercepted arc, all right? So do you remember the circumference of a circle is 2 pi r? Okay. Circles are 360 degrees, correct? So with respect to radian language, 360 degrees is equivalent to 2 pi radians. If 360 is 2 pi radians, how big do you think 180 would be? 1 pi radian. Let's go one further. 90 degrees. 1/2. So pi over 2 radians. Okay, so that explains the radian equivalent for your 360 degrees full circle and your half of a circle, and then a quarter of a circle. Okay. Now, when you're converting degrees to radians, we're always going to take the degree value and multiply it by this fraction. When you're going the opposite way, converting radians back into degrees, notice that this fraction gets flipped. Now, when you do this fraction and you're trying to get to degrees, I don't know if you recall from your some of your science classes having the unit of measure cancel. Do y'all remember doing that? Have y'all done that yet? You haven't had the units of measure? Okay. Well, our units of measure are going to cancel. These radians will cancel those radians as a unit of measure and leave me with 180 degrees divided by pi. All right. So what we're going to do is we're going to convert. The next 12 problems are converting. Okay. Now, I cannot have a decimal. I cannot have a rounded number whatsoever. So we're going to do this in exact values, and I'll show you how to type this in on your calculator. So I want to convert each angle to radians. So each degree is going to go to radians. Notice there are 3 positives, 3 negatives, because it doesn't matter. So I'm going to take 60 degrees, and I am going to multiply that by pi radians over 180 degrees. Now, the degrees will cancel. So I'm left with just radian value. So I get 60 pi over 180 radians. And then all you have to do from there is reduce the 60 and the 180. Don't touch the pi. Just reduce the fraction out in front. When you take 60 divided by 180, you should get 1/3. Do y'all agree? So that would be 1 pi over 3 radians. Now, you don't always have to put the 1. If you take 1 pi over 3 and you write it as just pi over 3, the 1 is understood to be there just like any other variable. Even though that's pi and we know that's 3.14. You do not always have to write the 1. So for the second one, we're going to take 160 degrees, multiply by pi radians, and I'm going to abbreviate that as rad, over 180 degrees. The degrees will cancel. So basically, you're taking 160 pi over 180, and you're reducing the 160 and the 180. So what does that reduce down to? 8 over 9. So that would end up being 8 over 9 pi. Now, you can put pi in the numerator. Don't ever put it in the denominator because it's not there. Or you can write it as 8 over 9 with a pi behind it. That's fine as well. All right, so I'm going to give you a moment to do the 330 and come up with the radian equivalent to that. And then I'm going to show you, try to visualize what this means. Did you get 11 pi over 6? Perfect. Okay. Now, what happens is, what's the difference between the 60 degrees and the pi over 3? All right. 60-degree angle. Oops. This is a 60-degree angle. The angle is 60 degrees. The pi over 3 part is the part of the circle that is cut off by that 60-degree angle. Does that make sense? So the angle itself is 60 degrees. And when you talk about pi over 3, you're talking about the arc cut by the 60-degree angle. Okay? So the same thing over here. We got 160 degrees versus 8 over 9 pi radians. 160 is almost to 180. So there's my 160 degree angle. So we're talking about this part of the circle, because that circle, of course, would keep going. But the 8 pi over 9 represents that aspect of the circle where the 160 is the angle value that cuts that arc. Does that make sense? So They're equivalent. Do y'all remember central angles and arcs? You don't remember central angles and arcs? If your angle is 60 degrees, if it's a central angle, your arc is 60 degrees. Okay? They're the same. So this is the same thing, but with respect to arc length, you're talking about that small portion of the circumference that goes with that angle. Does that make sense? So when you think about radians, you're not really talking about the angle itself. You're talking about the part of the circle that the angle cuts off, so to speak. All right. So negative 45 degrees. Have y'all already done these? All right. I'm going to give you a moment. You will have 3 negative answers. That's okay. You're just going to have a negative out front of your angle. Is it lunchtime already? All right, so we were at negative 230 times pi over 180. You should end up with negative 23 pi over 18. Because that would be negative 230 pi over 180, and you can reduce that. Negative 75 times pi over 180 gives me negative 75 pi over 180, and that reduces to negative 5 pi over 12. Any questions about the negative angle conversions? All right, so now what we're going to do is we're going to go backwards. Okay, so I'm going to give you the radian equivalent, and you're going to convert it into degrees. So we're going to flip that fraction. So we're going to multiply by 180 over pi. The reason we do that is the pi's will cancel, and then all you have to do excuse me, is multiply 5 over 18 by 180, and that will give you your angle measurement in degree. Did you get 50? All right. So number 14, 180 over pi. Cancel the pi's. When you multiply 11 over 9 times 180, you should get 220 degrees. Of course, when we multiply 7 pi over 3 by 180 over pi, your pi cancels. So whatever 7 over 3 times 180 is your degree value, which would be 420 degrees. All right, so I'm going to let you come up with these last 3 values. Right. So hopefully you were able to get those three answers: negative 30 degrees, negative 285, and negative 135. How'd we do? We do okay? Now remember, when you convert back and forth, you're just talking about a different part of the circle. The degree is the actual angle, and the radian is the arc that it cuts. So you're just talking about a different part of a circle. So the last couple of things that we're going to talk about, or the last thing we're going to talk about, is coterminal angles. Okay? Angles in standard position, that means they start on positive x. With the same terminal side are coterminal angles. And then it asks us to determine whether the angles are coterminal. So what happens is, if I have this angle right here, whatever degree measurement or radian measurement it is, and then I have this angle, do you agree that's a positive angle, but that's a negative angle? Do they both start on positive x? Do they both terminate with the same ray? Okay, those are called coterminal. Obviously not the same size, because one's a positive and one's a negative value, but that's what coterminals are. They begin at the same place, they terminate at the same place. Now, if I were to take and draw the little snail shell, that is a positive rotation, but that is also coterminal with the first angle that I drew. I could sit here and rotate around here 500 times, and as long as I stop here, rotating 500 times, and then that little extra would also be coterminal. So the coterminal angles, they begin on positive x and they all terminate at the same place. All right, so how do you find coterminals? Well, we're going to either add or subtract any multiple of 360 degrees. So I'm going to put n behind it, and n could be anything, positive or negative. Or you may have to do 2 pi, add or subtract 2 pi, depending on whether you're working with degree values or radian values. Okay? So here, since I'm working with degrees, what I'm going to do is I'm going to take 360, I'm going to subtract 305 from it, and if I get 55 or negative 55, then these things are coterminal. What is 360 minus 305? All right, close. Now, what happens if I take 305 and I take away 360? I get negative 55. Okay, so are these coterminal? Yes. When I did it one way, I got 55, but when I reversed the order, I got the negative 55. Does that make sense? All right, here, if I take 30 degrees and I add 360, I'm definitely not going to get 170. Do y'all agree? All right, so I'm going to go the other way. Actually, I'm going to take the angle itself. We'll just start with the angle, and I'll subtract 360 from it. What does that give me? It gives me negative 330, correct? Well, negative 330 is not negative 170. Do y'all agree? Okay. If I subtract 360 again, if I do another rotation, I'm way above 170. So these are not. So you can add or subtract any multiple of 360 degrees. Okay. Here, since we're talking about radians, this one's going to be a little bit trickier to do on our calculator. Does everybody know how to use your fraction button on your calculator? Okay. So I need to know if these two angles are coterminal with each other. So if I'm going from a positive value to a negative value, I'm going to take that positive, I'm going to subtract 2 pi, and I hope this number comes out. So what I want you to do, the way I want you to calculate this on your calculator, there's an understood 1 here. So I want you to actually do 1/4 minus 2. I don't want the decimal, I need the fraction. Negative 7 over 4. So now we're going to have negative 7 pi over 4. If I take the pi out so I can add the numbers or subtract the numbers, I can always put pi back in. Well, negative 9 pi over 4 is not the same. So these two angles are not coterminal. For this one, 3 pi over 2 minus 2 pi. So what I'm typing in my calculator is 3 over 2 minus 2. All right, negative pi over 2. Now, I want you to do minus 2 one more time. This is one rotation. This would be a second rotation. You can subtract or add 2 as many times as you need to get what you need, the desired outcome. Does that give you, so you had negative 1/2. Here, when you subtracted, you get negative 5 over 2. So it took us 2 rotations before we got to negative 5 pi over 2. So these two angles are coterminal. So the answer to that question would be yes. So you can add or subtract as many times as you need. Now, every angle has unlimited coterminal angles. Okay? In this particular example, they are asking us to give 2 coterminals, one positive and one negative. So this is real easy. We're going to take 150, we're going to add 360, that will give us a positive coterminal, and I'm going to take 150 and I'm going to subtract 360, and that will give me the negative coterminal. So when you add these two, you should get 510, double check my math. When you subtract, you get negative 210 degrees. That means that all 3 of these angles begin on the positive x and they terminate at the same place. It's just different rotations that they make. So here, 265 plus 360. That will give us our positive. 265 minus 360 gives us our negative angle. Now, if you were to do one and you subtract 360 looking for a negative outcome and you don't get it, subtract 360 again. You can subtract 360 or add it as many times as you need. So we got 625 here and negative 95 degrees here. And then negative 25 degrees, if you add 360, that will give you a positive outcome. If you subtract 360, that will give you a negative outcome and a negative coterminal angle. All right, now the last 3, they are in radians, so we're going to have to do the little trick with our calculator. But I'm going to say pi over 12 plus 2 pi. Technically, in my calculator, I'm going to take 1 over 12 and add 2, and then I'll put pi back in my answer. That will give you a positive value. You should get, 25 over 12? when you add those together. So that would actually be 25 pi over 12. And then I'm going to take pi over 12 and subtract. That should give me a negative outcome. If it doesn't, subtract it again. Okay, so you add 360 or 2 pi, and you can add or subtract 360 and 2 pi as many times as you need. So to type this in your calculator, take 1 over 12, subtract 2, and that should give you negative 23 over 12, and then you just put pi. Notice I keep putting pi back in the numerator. Don't put it in your denominator, put it in your numerator. So here, if I take 7 pi over 6 and I add 2 pi, the positive coterminal, and to get the negative coterminal, I'm going to subtract 2 pi. And I'm hoping that I get those desired outcomes. If you don't, add 2 pi again. If you do, stop. If you don't get the negative number, subtract 2 again. All right, did you get 19 over 6 and negative 5 pi over 6 for the second one, number 27? All right, so negative 11 pi over 18 plus 2 pi, and negative 11 pi over 18 minus 2 pi. The hope is that this produces a positive and that this produces a negative, because your directions do say give 1 positive and 1 negative. So what positive outcome did you get here? 25 pi over 18, and then the negative outcome? Perfect. Okay. Any questions about that? Now, the next page you can't tear off because you need the back. So, actually, yeah. The next page, it says Unit 5 Trig homework. What I would like you to do is just take out a blank sheet of paper, and I need you to give me all of the even answers. I do not need any of the odd problems. I just need 2, 4, 6, 8, all the way down through 18. When you are done with that, you can put those